that 1.6 is transformations of functions. And with the transformations, that's basically just shifting graphs. And this is the one thing that's going to come back. We're going to do this in chapter 1. We'll do it again in chapter 2. We'll do it again in chapter 3 just a little bit, and then we'll come back again a little bit more in chapter 7. So it's one of those things that we're going to change how the functions look, but the same basic principle is going to be the same in each one of those. That if it's here, you do this. If it's here, you do this. And we're just going to replace square root with absolute value, with log, with exponents, with fill in the blank, but it's still going to have that same basic idea of what we're looking at. And the big thing they look at in section 6 is that you've got a few. Now, they talk about doing linear functions, but we've done enough with slope and everything else back in sections 4 and 5. We don't really have to worry about it. Here's the other functions that they look at. These are the ones you have to kind of know the basic shapes of. If we talk about graphing absolute value of x, the basic shape of absolute value of x is going to be a V-shaped graph. You're also going to do square root of x. We're going to do x squared. We'll do x to the third. And I think they do the third root also. Now, the one thing on all these graphs is that they're all going to have 0, 0 as one point that they're all going to share. One more graph there. Yep. So the big thing on those 5 graphs, and again, they talk about linear functions, but we've done enough with slope and intercept that we don't really have to worry about it here, is that with everything that you do with these graphs, whether it's a cube root or square root or x squared or square root or absolute value, here's what they want to try to get you to see. Again, 0, 0 is kind of a reference point for every single one of these. It's either the middle of the graph or it's the start of the graph if we're talking about absolute value. Everything else, it's the middle here, it's the middle here, it's the middle here. You know, it's also the middle here. And the one thing you want to kind of get through these is that the one basic thing that kind of goes through this is this. If you add or subtract, and that's kind of the key thing on this part. Whether it's the addition subtraction part that's going to shift the graph as you're going through these. But if you add or subtract on the inside of the, and this is where you get to fill in the blank, whether that's the absolute value whether that's the radical, whether that's the square root, or whether that's the third root, or if that's just the parentheses. We're talking about x squared and x to the third. But if you add or subtract a number that's on the inside of the absolute value with x, then it's always going to result is an opposite horizontal. They call it translation. Basically, it's a shift is what you want to kind of look at it here. Sometimes they call it translations, but it's just you're moving the graph left and right on this part of it. And probably what they'll do for some of these, and they'll kind of mix up exactly what they do with this, is they'll start off by saying maybe having your graph f of x is equal to absolute value of x. And then we're going to graph absolute value of x minus 3. And we'll wind up putting these on the same graph just so you can see exactly what's going to go with them here. Okay, now here's where before they made you graph, plug in 5 points or 6 points, ever how many points it was, you had to plug them back in, get the basic shape of it, get the dots in the paper, go back, connect the dots. You're not going to do that for me on the test. We're doing this paper and pencil because all I'm going to do is I'm going to say, here's a graph, give me the basic shape of it. And really what I'm going to look for is I'm going to look for where all these points back here, all these graphs had 0, 0. I'm going to look to see if you moved this thing, if you shifted it in the right direction, up and down and left and right. You've got that pinpointed there and you've got the basic shape of the graph. That's all I'm worried about because there's a lot of stuff we've got to get to. So I'm not worried too much about that. So if we do absolute value of x in blue, it's a V-shaped graph. It'll look something like that. Okay, with absolute value of x minus 3, well, now we're going to shift it 3 spaces. Now here's where we're going for this one. Because for this part of it, we're going to scoot it 3 places, but we're going to go the opposite direction. Normally you think 3 spaces to the left, but you're actually going to go the opposite direction. You're going to move it 3 spaces to the right, so that would be the same graph that's here. But we're going to just scoot it over 3 spaces to the right. Now, most people usually go, well, why are we going in the opposite direction? What you're doing when you're using the inside part of that one, you're basically finding out what the x-intercept would be, where it crosses the x-axis. That for that part of it, you're basically taking what's on the inside. And you're saying, all right, where's that going to cross on the x-axis? Because that's your side-to-side movement. To make this part equal 0, well, you're going to add it away, so then we're going to have the x equals 3. So that's kind of giving you the x-intercept part of it, if you want to look at it that way. Oh, now the one thing they may do on this one, and this is where they'll tie back in where we did a couple of sections ago. They may ask you for domain and range. Okay, and for this one, you can plug in any number you want to, whether it's absolute value or absolute value of x minus 3. This one, you can plug in any number that you want to. So this would go from negative infinity to infinity. And for your range, that's your up and down movement. So all we did with this graph was just slide a little bit left and right. We didn't change anything on the up and down part. So for this one, it definitely is going to start at 0. And that's going to go up in both directions. So it'd be from 0 to infinity. Okay, now if you want to, let me go back up here. That's one thing we should have done with the graphs back up here. So this one, domain was from negative infinity to infinity. The range was from 0 to infinity. the only graph that's here that's not going to be negative infinity to infinity for the domain is going to be the absolute value of x, because that one you're not able to take the square root of a negative number and get a real answer. So this is the only one that's the domain is going to be anything other than negative infinity to infinity. This one, 0 is your bottom as far as you can go. And then your range is going to be the same thing. X squared domain is still negative infinity to infinity. Range is also 0 to infinity. So those have basically the same domain and range there. X to the third you can plug in any number you want to, so it's negative infinity to infinity. The range is going to be the exact same thing because there's always an answer you can get out of this part of it. With x squared, anytime you square a number, it always makes it positive, so that's why 0 is the cutoff line on that one. And then the last one with x to the third, it's basically the same graph we've got with x cubed. It's just a little flatter, but it's still going to have the same domain and range as x to the third. So your domain is going to be negative infinity to infinity, and then your range also negative infinity to infinity. And some of the questions they may ask you about those, some of them they won't, they'll just let you graph it. But just in case they ask you for domain and range, that's your basic. Now again, if you start shifting it up and down and left and right, it may shift the values. For this one, it didn't change anything because the domain and range for both of those is the same because because whether you go negative infinity to infinity, whether you scoot infinity 3 spaces to the left or 3 spaces to the right, it's still infinity. It's just a little bit slower, a little bit faster to get there. Right, we're good. Okay, now you got your other option here. If you add or subtract a number on the outside, that if you put a number on the outside of whatever it is we're doing, if it's absolute value or parentheses or radical, then it's going to have not a horizontal impact. This one's going to give you a vertical. So if you add or subtract a number on the outside of the absolute value, let's say the result is a vertical shift. And for this one, it's the normal direction. Because with this one, you'll get whatever the answer is from the first part. Then you're just, if there's something on the outside, then you're just, if you add 3 to a problem, then you're taking every answer you have and you're adding 3, so it's scooting the whole entire graph of what you're going to do up. Or if it's a minus, then you're going to scoot the graph down. And for this one, we're just going to skip the first part. We'll just go straight into giving you one to plug in here. Let's say we're going to do x to the third plus 4. Now, the bad news, and this is where if we're doing this one by hand, if it was me, this is one of those where you could graph this thing really quick on a test. On online homework, it's going to take a little bit longer because they're going to make you graph 2 points, basically. You've got to have a reference point of where you're moving this thing to, your up and down and your left and right movement. You plot that point, and then it's going to have you got to pick the shape of graph that you want, whether it's x to the third or whatever, and then you've got to plot one more point to make it all match up once you do that. So once you get the 2 points, it fills everything else in for you, but you do have to go back in and plug in one more value. So if it was me and we're doing this on the test and it's paper and pencil, here's all I'm going to ask you to do. We're going to go up 4 because there is no parentheses, there's nothing, so that's definitely on the outside. And your graph would just basically be to do something like that. And that's all you have to do. Just quick and easy. Just get the basic shape of it. Now, don't do this, because I can't tell if is that x to the third, is that x cubed? It's still got to have the same basic shape of what we're looking at. It's got to be close to it. Test-wise, on the homework, once you plot this point and you click on this basic shape of the graph, once you plot this point, as you start to move the mouse, it's going to start trying to draw this thing in. So you've got to pick one more point to plug in. So you may just have to plug in x equals 1. I'd pick the next number, pick the easiest number you can pick to plug in. If you plug in 1, it's 1 cubed plus 4. So that means you have to go to 5. So if you go to 1, 5, you'd have to have that point as a reference point so you could plot that, and then it fills in the gap and does everything for you. So online homework, you're going to have to put, now they may ask you, sometimes they'll ask you about just if you pick the right shape, and they may ask you, what was the vertical translation of it, what was the horizontal translation of it, and then was there any kind of reflection. So sometimes they'll have you just fill in some information and they'll draw it for you, and they kind of go back and forth on those two graphs. So a little bit more work that you have to do for the homework, but if we're doing this on a test, just a quick sketch is all I'm going to need. All right, let's give you one that's got both of them here. All right, so let's go to the square root of x plus 2 and then minus 4. Okay, so the plus 2 on the inside means you're going to go opposite direction, so we're going 2 spaces to the left. The minus 4 means we're going to go 4 down. So then from 0, 0, basically do that. Go 2 left, and then 1, 2, 3, 4 down. And for that one, that would be your starting point that we're looking for. Again, the only thing that's going to change, if we changed out this to make an absolute value, it'd still be the same thing. You'd go 2 left, down 4, and then just the basic shape of it for square root, it's basically half a graph. So it's going to take off and do something like that. Okay, we'll do domain and range on this one. Okay, normally for square roots, it starts at 0, but again, x values, this is basically your x value here. We've scooted everything 2 spaces to the left. So instead of starting at 0, now we're going 2 spaces left of that. So now we're going to start at -2. Go to infinity, and your range, that's your y value, which is this part. Now we've scooted everything down 4, so instead of starting at 0, now we're going to start at -4. So if there's any impact on your domain and range, anything on the inside is going to impact your domain. Anything on the outside is going to impact your range. Okay, and then the last thing that they throw at you, as far as how everything fits with the graphs here, is reflections. But it still comes back to the exact same thing that was in the other two. Where it is tells you what kind of reflection it's going to be. If you have a negative that's inside, and if you want to, we won't list everything out. But if it's inside the fill in the blank, those absolute values, the parentheses, or the radical, if it's on the inside, it's still going to have it so it's got that impact of it going side to side. And if you go side to side, you're eventually going to cross over. You're going to stay on the x-axis. So what you're going to do is you're actually going to go across the y-axis. So this is one where they would say if you have a negative on the inside, it's going to be y-axis symmetry or a y-axis reflect. How do they word it here? Y-axis reflections. So a negative inside the fill in the blank. So that'll be a reflection of about or around the y-axis. And if you have a negative outside of the, again, fill in the blank of those three things, it's going to give you a reflection about the x-axis. Yeah, so where everything is tells you what it's going to do. And depending on the graph, sometimes when they give you one of these, we'll do one real quick here. Now, they shouldn't get too complicated because they're not going to make you do like 3 or 4 different things. Most of the time with reflections, they're just going to make you reflect it, and you're not going to have to move it, shift it up and down and left and right. They'll just give you a basic one and say, okay, here's the function we've got, and then let's graph this one and see what you can do with it. So let's say that you've got f of x, and let's say we're going to do negative. Let's get you one and make sure you can see it real well. Let's say we're going to do negative square root of x. Okay, so you don't have to draw this. I'm just kind of getting this for visual. There's square root of x. And again, if the negative is on the outside, that's going to make everything go up and down because it's out. Anything on the outside makes it go vertical. So now instead of it going up, now it's just going to go down. So basically, we're just taking this graph that's up here above the x-axis. Now you're going to flip it and drop it down below the x-axis. Where if we had the negative on the inside, yeah. So instead, so this, yeah. So now everything that you need to, you got to go in the opposite direction instead of going down. You're going back this way. So that would be your square root of negative x. Because it's on the inside, it's going to make it go side to side. So now instead of it going to the right, now you're going to make it go left. So anything on the inside is going to make it go change directions side to side. Anything on the outside, it's going to make it change directions up and down. And that's the whole thing they're trying to get you to see on this one. And that's where when we get to chapter 2, we're going to change it. Instead of talking about absolute values and square roots, we'll talk about something else. When we get to chapter 3, we're going to talk about logs and exponents. And it's still that exact same thing, that anything you do that's on the inside of the fill in the blank is always going to have horizontal impact. Anything that you do on the outside is always going to make it have a vertical impact. And that's the whole big concept they're trying to get you to see that's in chapter 1. And they'll just keep coming back to it, and coming back to it throughout all the different chapters we'll get to. Not a whole lot, no. It's one of those things where they'll show it to you, and you do a little bit with it, but you don't do like tons of graphing with it. Because we'll hit it here in section 6, and we don't really do. We'll do a little bit of graphing in section 9, and that's in chapter 1. That's about it. Chapter 2, I think we hit it in 1 or maybe 2 sections, but even then, it's not like the whole section. It's just a couple of things in there. So it's really not as bad as what it sometimes seems like it is. Yeah, everything else is just they give you different problems. You plug it back in, and then you just work on shifting the graphs and kind of moving through it.